Hello, and welcome to the eTech podcast with me, your host, Ryan Maughan. I have been involved in the development of electrified vehicles and machines since 2005 as an engineer and a business leader. This podcast is the product of my passion for electric and autonomous vehicle technology. I'm here to share knowledge from some of the world's leading experts, as well as my own insights. Join me as we accelerate the transition to cleaner, safer and smarter vehicles and grow the industry around the world. So for today's show, we've got a really interesting episode. This is a company that I met a few months ago, had the opportunity to go and visit some of their facilities, and I was fascinated by some of the technology that they had relating to testing and systems testing in the electric vehicle space. So we've got Davide Tessore, who is general manager at Marposs EDC, here to talk to us. So welcome to the show, David.
So thank you very much. Thank you, Ryan.
And if we could just get started, really with a bit of background about yourself, you know, tell everyone who you are, where you're from.
Yeah, sure. Well, I was born in Torino. I live there. I am a mechanical engineer. I graduated in Torino, and then I worked in the past 15 years for AVL. And there I learned a lot of things about end-of-line application, but of course starting on an internal combustion engine. So I basically developed my 3/4 of my career in internal combustion engine,
right?
Specific on end-of-line application. Then, of course, we started also at the time to get involved into electrification business, and that's where in the last period I was contacted by Marposs,
okay,
to reach the current position I have and to basically integrate EDC, which was one of the last company that the Marposs Group purchased and acquired, and to make it the business unit for electric motors of the Marposs Group.
Okay, and just to sort of go on that early time, I'm guessing. I mean, I've been fortunate to go to Torino a few times. A lot of automotive industry in that area. Growing up there, was it always clear to you that you wanted to go into engineering and the automotive sector, or was there something that really got you interested in it?
Yeah, engineering was one of the two branches that I was really looking after my liceo, my college, how it's. And mechanics was really my thing at the time. Automotive became what the market was looking for.
Yeah.
And it was then quite clear then that I was really enjoying being involved into production processes and more than into the product development itself, into the final car development.
Yeah,
I got myself into these production processes and environment, and it was it was very nice for me. It was a very good experience.
Brilliant. And of course, so big change for you then to move to EDC Marposs. But do you want to just tell us a bit more? Because I know, Marposs is not a company I'd come across before myself. So it's a fascinating business. So if you just tell us a bit more about the group.
Yeah, sure. Well, Marposs is a very large group. Was founded in 1952 in Bologna, and it's a company which is started with also involved in production, in measurement, and it's in the last 20 years, it has acquired a lot of other companies like EDC, specialized in very different application, becoming so a very broad company with a large portfolio that can really basically satisfy every single request in the measuring business and in the electrical vehicle testing and measuring itself. So it's a very nice group in which I also, in my current position, I find a lot of interaction and a lot of possible integration with other business unit and other company of the group. So it's an Italian group. I said it was founded in Bologna by Mario Possati, which is the engineer who gave the name to the company. And now it produces a lot of standard system and a lot of special machines for special application for measuring and testing, basically.
And there's a range of technology from quite basic gauges and kind of things like that, right, to lasers and gas sensing, and like it's a mind-boggling.
Yeah, probes. So very, very small and let me say compact application to complete machines, fully automated for measuring application from internal combustion engine to EV to aerospace, as well as to medicals, and well, really, it's really a wide portfolio.
And then, so EDC is a business. You mentioned Marposs acquired that fairly recently. So what's the background on EDC?
Yeah, EDC was it's more or less a little bit younger than Marposs. It was founded in 1964 and has been specialized in the e-motor testing and subcomponent testing since then. So starting from stator, rotor, even single wire testing to the complete e-motor. And of course, it has e-motors are a technology which was always present since 1964, but in the last years, as everybody can see, is really impressive the big push from the automotive market on this on the implementation of electrical motors in the field. So it's really overwhelming how many different application and requests we are getting from customers which were in the past not EDC customer. They were Marposs customers, and now they are really developing solution that we are able to test and to assure the quality of.
Yeah, so I guess the interesting thing for EDC as a business is the electric motor has gone from being a small component, maybe a starter motor or an alternator or a actuator motor for some sort of wipers or something like that. Windscreen wiper motor, yeah. Very important, safety critical motor, but not quite the same as a traction machine for main propulsion. So now the whole market is really, you guys were there really early on developing this capability. But now, is there a big change? Now it's going from being those sort of ancillary motors to being main propulsion motors. Do you see different demands from the market?
Well, for EDC, not really. But this just because we were already testing motors, for example, for lifting system, for transport system. motors for even up to mid-tension system. So the size of a traction motor is not something that we have never seen in the past. It's really is known. Of course, the technology of a traction motor is something new. Also, not new as a complete as a principle, as a working principle, but in the details, the technology jump that is currently applied to these traction units is impressive also for us to see.
Cool. So yeah, I mean, I didn't realize it's a medium tension, medium voltage. So that's like 2,000-3,000 volt systems, I guess, for trains and things.
Lifting system also is it's a typical application.
Very critical. Yeah.
Different customers for those, and of course it's very different from a wiper, but it's typically bigger, much bigger than a traction motor, even if normally not so powerful. So what is really impressive in the traction motors is the power on sides ratio.
Yeah. Okay.
Power weight even.
And I guess that, well, it sort of leads into the particular technology that really caught my attention when I visited EDC, which is why I asked you to do this podcast, and I'm putting you through this the pain now, was the partial discharge technology. And again, it wasn't something that I had come across before, but it was like a bit of a wow moment for me seeing partial discharge testing in operation on an electric motor. So yeah, tell us about partial discharge testing.
Let's first talk about some electrical safety tests. Okay, so typically electrical motors undergo first static session of test, where tests like dielectric strength or surge test or hypot test, as they're normally called, are run to check if the assembly quality of the motor is good enough, and if there are major problems like short circuit and inappropriate contact of different phases in the assembly have occurred. Then partial discharge go beyond that. So partial discharge is like an extreme magnifier on the defects that you could be able to detect with surge and high voltage, traditional surge and high voltage application. And it goes even beyond, because it can detect what we normally call a latent defect. So a defect which may not endanger the motor performance at the time of the test, but that can get worse and endanger the performance maybe after 1,000 hours of application, 100, 1,000, 10,000 hours of application. So the partial discharge is technically a small spark occurring in an isolated bubble within the insulator of the wire. So this spark is not powerful at all. It's really small, and it doesn't go from one side of the other to the other of the isolation.
Yeah.
So it cannot be detected with an high voltage or with a surge test, because actually in that moment of the test there is no spark occurring.
Yeah. High voltage normally relies on effectively, if you've got like an almost short circuit or an actual short circuit, you're jumping the gap, and yeah.
Exactly. You have polarized the complete insulation, and you got a transfer of current.
Yeah.
So you see that there is a defect in that very moment.
Now, this was because my engineering brain understands that. Like, okay, yes, we have current, so we can see that. If we put that in, we have a current flow where we weren't expecting, and I get that. But partial discharge, when I saw it, is like, how is that even, how is that possible? The physics behind it are quite interesting, aren't they?
Well, you are measuring some interference in what you're reading, and there you are measuring. You're measuring this during the surge or during the high voltage. So you run anyhow. You apply a voltage to the unit. That can be even a wire, and a couple of wire, and you increase the voltage, for example, up to a level where our machine detect these sparks. There are two methodologies for detecting these small sparks. One is by an antenna, and the second is by analyzing the behavior of the energy in the conductor themselves. And this is the second technology what we use, because we have developed this solution to be used in production and not only in a lab. You know, if you measure something with an antenna, you are subject to all the possible environmental noise that you may have, even a mobile or another machine testing something else different in a few meters beside you or whatever. If you are testing this by our methodology, you can do it directly in a production plant where all the different machines are turned on and working, and you don't get any kind of disturbance.
And I know there's some sort of secrets to it, but in essence, you are effectively counting electrons, and you're looking for an electron going missing.
Yes.
If it goes somewhere it's not supposed to.
It's something like that. The detail of our measurement are it's not something I'm really able to explain in such details. The idea is that yes, we apply a current, an AC current, it has to be, and can be an impulse, so-called surge, can be sinusoidal waveform, and during the execution of the test, we measure what is our system is able to measure and to detect when this PD are happening.
Yeah.
So it's basically the acquisition of the instruments that give this kind of reliability and this kind of sensitivity, let me say.
Yeah, because it's a special piece of hardware actually that you use to do this
Yes.
as well. So it's not like just a software it's actually dedicated hardware and really quite a complex system developed, but quite simple.
No, yeah, let me say there is beside the measurement process, which is quite complex, what is really also important is how good the machine has been built, the measuring machine, because in the end, it is so sensitive that if the testing machine is not built up with the proper quality and technology, you can measure the partial discharge of the machine itself.
Yeah.
Or the partial discharge of the connections. So it's really important that you are very consistent and sound on the instrument to isolate the possible defect of the DUT.
And it's fascinating to watch this test happening, because you've got some really great examples that you show people when you're demonstrating it. But the normal tests that I'm used to, that I think most people in the motor industry are used to, you like we said before, you can detect a short circuit, or if you've got something that's almost a short circuit, it kind of brute force, you can cause breakdown in insulation. It's not quite right, but that's really it. So you're looking for defects in the insulation system basically, and that's where the testing stops. But the thing that was kind of like a real wow moment for me was the demonstration where you were then checking for things like the presence of the slot liner. So it was possible with the partial discharge machine to see quite a lot of other manufacturing defects on the motor, in addition to a potential short circuit, because you were looking for things missing from an insulation system, or which with the normal test you just wouldn't be able to see these things. But it's amazing what you could see.
Yeah, it is, and is also very important for our customer, because it gives them the peace of mind that their system is not only okay at the moment of the test, but is also built in a way that will allow it to work properly for the desired life. So if I have a stator which is where I measure partial discharges at a voltage that that stator will never see into his life, that piece is somehow perfect.
Yeah,
it works fine, and our customers are good to install that into the final application. Everything can at a certain proper voltage create a discharge. So Dr. Pariani, which is the previous owner of the company, and who is a very, very expert technician also on this, always like to say, okay, if I put to create a current on the top and the bottom of a desk to 1 million volt, well, I will definitely create that discharge, even if I'm talking about a 5 centimeter thick piece of wood.
Yeah.
The point is that there is always a voltage in which this phenomenon are able to occur. It always happens.
Yeah.
But it can be a voltage that is not seen in the life of the product. And that's what we are going to ensure. And right now, this is becoming very, very important in automotive, because the traction motors are always driven by inverters.
Yeah.
And inverters are particularly prone to create this overvolt. And the second is that also for to reduce weight, typically there is a tendency in the automotive to reduce the current and increase the voltages.
Yeah.
And it also contributes to this problem. So to be sure to effectively find out these defects is very, very important.
And there were things like you could see if a motor that was encapsulated, that if there was an air pocket, the encapsulation hadn't been applied correctly, that showed up as a result. You could see on hairpin windings, you could see faults in the system and problems with welding. I mean, it was the sort of array of things that you were able to see with the equipment was quite staggering and seemed to have a lot of applications. You know, obviously there's the normal stuff with looking for the insulation system on the wire, but a lot of other aspects of the motor were also effectively being checked with the test.
Yeah, sure. Well, what we are testing on a normal winding are the problems that are typical of the winding process. And what we are testing on an hairpin system, of course, is mainly related to the forming, for example, as well as to the installation of the hairpins into the stator. So while the winding is, well, for some reason, is really more complex because having to assembly wires which do not stay in place, which are soft and can bend, it's even more complex. But testing on hairpins means that we need to create a reliable test to check that the forming procedure, so the procedure to bend the hairpin in the right shape to fit it to the stator, doesn't create any issue in the insulation film. And this is particularly critical because the elbows and the turns of the hairpin are sometimes quite complex.
Mm. Yeah, well, they're bending in very tight angles in 3 directions and things. Yeah. They're easy to be damaged. So, I mean, it is. I would actually recommend people to sort of check it out, basically. And I know we're getting back to trade shows and actually seeing people in the flesh and stuff like that. But it's something that I had to see it to kind of understand it, which might be my shortcoming, but I would recommend having a look. And obviously, in addition to this, the partial discharge test, so you make stator testing equipment and partial discharge tests, but it's fair to say there was a lot of other very nice bits of test equipment as well. So tell us the other kinds of things that you do at EDC as well.
Yeah, of course. Well, we are able to develop solution for the entire assembly process. So we as EDC are able to test from stator to rotor to the complete motor with no load or even in a full load test bench. So for R&D application or as well as for end of line application, we are anyhow able to test the functional aspect of the motor, the functional, let me say, functional test of the inverter itself. And so we can complete all the electrical tests. But the Marposs group itself can add to this also the visual inspection and measurement and gauging of the subcomponent of the e-motor upstream to where EDC is then getting involved. and therefore we are in a position that we can provide basically every single testing machine on a e-motor production line, not to mention a battery production line or many other applications. But we are not here to talk about internal combustion engine, but even there we would be close.
No. Well, maybe we might come back to some of the other test systems another day. So it's kind of the EDC Marposs bit of the business, the state of testing, partial discharge, which is really interesting technology, but then you've got a whole host of other bits of test equipment for testing rotors, stators, complete machines and axle systems, and it just kind of keeps going on and on and on actually. And the other thing that was really nice to see was the reach that you had as a business, because based in a fantastic part of Italy, but you really were, you supply a truly global customer base. So I think people would be surprised or maybe not surprised to see some of the really big names that you're supplying equipment to.
No, well, really. EDC is exporting 75% of its production. Marposs is exporting up to 90%, even more than 90% of its production. So we are both companies, both companies are really engaged worldwide in the supply of testing system and measuring system. So it's a perfect fit for EDC to be into the Marposs group, into the Marposs organization, and to take the advantage of being the competence center for motor testing of such a market leader company.
And it must be, I don't know, I mean, a lot of companies in the automotive space at the moment, they kind of have some problems because they've got a big part of their business is relying on combustion engine, and they see that reducing and falling away. But I think maybe across the wider group that might be a challenge. But within EDC, it sort of feels like you're at the right time in the market, really, to grow a huge amount compared to where you've been because of the explosion in electric motors for drive systems and actuation systems. Are you seeing very large demand for the products, or how's that looking?
Yeah, it's actually looking really demanding. So the market is really exploding. Even the market of even our traditional customers are increasing their production. So there is really it's like a golden era for electrification in many aspects and in many applications. So of course, EDC is not the only one or the only company in the Marposs Group which is dealing with EV. That there is a complete portfolio of solutions, but it's really widen up the horizon on all this kind of application. Yes, and we are looking forward in the next future also to non-automotive new use of electric motors, like for example aerospace.
Okay.
Traction for the aerospace. This is something which is not for this year, not for next year, but it will come. And we have e-bikes.
Yep.
E-bikes, it's a tremendous market, really. And e-motorbike, so electrical motorbike, it will be also next application. So it's really improving. It's really expanding a lot.
Yeah, I agree. Yeah, and non-automotive aerospace is huge. Robotics is huge. Lots of growth opportunities there. So, how as a business are you managing all of that growth? That must create some challenges.
Yeah, it is. It does, of course. It does. We need to grow up in a sustainable way, and this is always a challenge because, of course, you need to be how to say you cannot be too much conservative, otherwise you lose your market portion. So
yeah, you kind of end, if you hold back too much, you end up effectively either creating competitors or
Yeah, it's much more. It's more to be able to work in a uncomfortable growth position, but this is also what keeps our moral very at the top.
Yeah.
It's really nice to see for me, but for all the colleagues to see how much this business is growing up, and even if can be scaring, it's really also engaging.
Yeah. And then, if I remember rightly, was there a plan to move to bigger premises and things in the next year or two to add some extra space?
Yeah, well, we had the chance to create some additional space at the moment here in one of the two buildings that we are in. And so at the moment we have delayed the move to maybe for one or couple of years.
Okay.
But of course it will be, well, it will come because the business expectations are really huge.
Well, there's never a good time to do that kind of thing because it's so disruptive. So you got to kind of putting it off. Yeah, you got to get through it at some point.
Yeah, sure. Well, I had already this experience in my past experience, and it's not easy, but if can be organized and planned in a good way, today it's much easier than in the past. Yeah, if you consider that we have worked for months in 100% smart working, and we have worked.
Yeah.
This is helping also in this kind of situation. So the network infrastructure and the possibilities given by the software, as we are demonstrating in this very moment, are
don't tell everyone we're not in the same place. No. Yeah. No, these are. You're right. There's a lot more. We don't all have to go. Those traditional models of everyone being in the office every day are very much not. They're gone forever now, I think. And this kind of thing, using tools like Teams and Zoom and things like that, it's definitely here to stay. But it's good to be with people some of the time, obviously. So just looking forwards then, as a business, and for you personally, what do you see coming? What are you most excited about for the future? What's happening in your space that you're excited about?
Well, what we're looking for is really to expand our range of product here. Talking about the EDC future in this moment. So really looking to expand our product portfolio to the new powerful traction motors and to different inline application. We would like to also expand into the axle business. which is the next.
Did you say axles or e-axle?
E-axle.
E-axles. Okay. So testing at that next level up for the full axle system.
Yeah, it's an application which we are confident to be ready to test in the next future coming this year.
Excellent, brilliant. Well, and I'm sure that there's going to be a lot of new opportunity and business growth for Marposs Group and particularly for EDC. And that the partial discharge testing technology is absolutely fascinating. Not sure we could quite do justice to it on a podcast, but I thought it was important to try and share that with people that maybe hadn't seen it before. So thank you so much for taking the time out today, David, to talk to me. It's been absolutely fascinating, and we'll I'm sure pick up again at a later date.
Yeah, thank you very much. Thank you, Ryan. It was a pleasure for me too.